Hello everyone, it's indeed inspiring to see you back again. And today we are going to discuss a solution to data modeling task. So let's begin. Now I'm sharing my screen and you can see on the screen there is a case study. This case study is of university system. Now, whenever you are in discussion with a customer or a client, then you need to understand their requirements. First of all, we need to go through the whole requirements and we need to identify that which are the major data entities present here. So let us do that practice. This is a solved case study. So I will take it by reading and by doing it. And at the same time, I'll show you that what exactly is the solution to it. So here, university system information description is given. Informal description is given. So ABC University is a large institution with several campuses. So just by reading the first line, I get to know that there could be an entity with the name campus. So I can list down entities over here. So campus could be one entity. Then I will read it ahead. Each campus has a different name, address, distance to the city center, and the only bus running to the campus. So here I got another information that yes, campus is an entity and campus entity is having certain attributes, fields, and they are like name and address and distance. So these are the attributes, and there's a bus also. So I can write it as bus number. So there's a bus also. So when you are starting the discussion or when you are reading the requirements, you need to pick up the entities. We had a discussion that we have conceptual data model, then we have logical data model, and then we have physical data model. So when you are starting, then that is the conceptual data model you are starting with. So I have written one entity, then I'm going to read more on it. Each campus has one club. So club may be an entity. So I will write club also. So club. The name of the club, the building in which the club is located, the phone number of the club, and the multiple sports which club offers should be all recorded. So club is also an entity. So I'm writing club. So there is a name of the club. Then there is BUILDING, building of the club where the club is located. And phone number is also there. And we have multiple sports. So I'm just writing sports here. Maybe I can write sports ID, or I will have to create separate entity for a relation between club and sports. So I'm writing SPORTS, sports, as a separate entity over here. So all these things needs to be recorded. Similar way, now you can go through the whole case study and you can keep on taking out the entities like this. So this is conceptual data model. Then while going to the logical one, you need to get into the details. For example, so campus. So for campus, you will have to mention that name. Is it the primary key? No, name is not the primary key. It's a normal column. Address, is it the primary key? It is also not the primary key. Distance is also not the primary key. So you have to write all the attributes and you also have to identify whether they are some important primary keys or any other type of foreign key or not. So I will give here campus ID because I know that primary key is an important aspect. So I will name it as primary key. And then because I'm into logical, I will also define the data type. So I will give integer data type. For name, I'm giving varchar or string data type with size of 30. Address, again, I'm giving varchar, and the size I'm giving for address is 100. Address could be longer, larger. Distance could be a float value. And here 10,2 I'm giving for decimal point, I'm giving 2. Bus number, I can give it as varchar. So varchar of 30. So this is how what I'm trying to do is I'm trying to create logical data model because I am getting into the details of this particular table. Now, moving further, what I will be doing for club also, I will do the same thing. So for club, we have club ID. Then for club, next thing would be name of the club. Then we have which building the club is located. And then we have phone number, and we have sports. Okay. And then we have something called as sports as well. So sports. So here I will have sport ID and sport name. This much. Okay. So I'm creating a sample. I'm not taking the whole reading of this particular requirement. I have taken only 3 tables. Now I need to see that there is a relation between club and sport. So I will create one more table here, which is CLUB club, SPORT sport. And in this one, I will just put club ID and I will just put sport ID. So you can see that this club ID is a primary key here, and it is of integer type. Name is varchar, so I'm taking it same from here. So name is varchar. Building name, it is also varchar. Phone number, I'm taking it as varchar only. And sports, so I'm now removing this from here because we have another entity which is club sport, which is making a relation between the club and the sports. Similar way, this one is primary key. It is primary key. And it is also int. Then sports name, this one will be varchar of 30. And here if you see, these both are foreign keys and int. This also foreign key and int. So this is how we are able to identify that they all are okay. What is their data type and what is the size? This is logical. And into logical only, we go and we try to create the ER diagrams. So let me open my workbench here, MySQL workbench, and let us see that how can we create the ER diagrams for this particular case study of university system. You can, after creating the ER diagrams, you can easily identify the relationship between foreign keys and primary keys, which are creating relationship between tables. It will be very much visible to you. And let me open my MySQL command line as well, where we will be able to finally see the physical data model. So this one also we will be looking into. So let me put the password. Okay, all right. Fine. So the workbench window is open, you can see here, and I will get into the instance with the help of root user. I'm logging in into this particular instance. So here I will be creating a new data model, and I'll be creating an ER diagram. And after creating the ER diagram, we will work on the MySQL workbench only to forward engineer the ER diagram into tables. So I can go to database, or basically I can start with file, and with a new model, let me start. And then we will go to database and will perform the forward engineering. So this is a new page open, and I have my notepad file here for reference. So I'll be creating these tables here. So let me create, so add a table. So I'm adding a table here, and after adding the table, I will be giving the yeah. So yes, a table, this is the table, and let me give it a name as, the first table should be campus. Okay, so I'm taking the name from here, and it should be campus, and it should have columns. So I have campus ID, so I'm taking campus ID from here, and it needs to be primary key. So campus ID, and it needs to be primary key. I'm just selecting PK primary key over here. Second table, Second is the name. So I'm taking name from here. It is varchar of 45. So I'm keeping it default. Next one I'm taking as address and I'm putting it here. So this is address. Next one is distance. So it's a float value. So I will put the distance here and I will take it as, just click here and select the float value. Okay. So float of 10 by 2 you have written. So take it as float. Yeah. So let me check the float number here. So decimal double float. Okay. So float I have taken. Fine. So it is float now. The next value is bus number. So this was distance. Okay. Certain things have changed. Okay. So let me make it as distance and yeah. So this one, let me delete it. Okay, fine. So the last one, let me edit it. Do we have something else? Bus number we have. So let me take it as bus number and it is done. So the first table is done. Similar way, you can create multiple tables. So one more table I'm adding. And so after adding one more table, we can go for now the club one. So club table has got club ID as primary key. So this is club table, club, and its first column is club ID, which is integer and primary key. So not null. And then we have name. So I'm just keeping name only. Okay, because now you understand that how you can add other things. So club ID and name, two things I'm adding. Let me add one more table. And to this table, I will name it as sports and I will add sport ID, S-P-O-R-T, sport, and sport ID is the primary key. Then let me select it as primary key and sport name. The second one, I'll take it as sport name. And here I'm mentioning the sport name. Okay. Next table, I'll take the relation between club and sport. So add a new table. So this is a new table added. And this is CLUB club and SPORT sport relationship. And here, if you see, I will be putting this as the club ID because club ID I wanted. And next one, so I'll remove it as a primary key. Next one, I will keep it as SPORT sport ID. So club ID and sport ID, these two things I'm taking. This also I need as integer. So let me select integer for it. So now you can see I have two things. Now I will have to mention foreign keys here. Below you can see foreign key. So foreign key name. So I will name it as club underscore ID and reference table. So which table to refer? So I need to refer the table club. And from club, I need to select club ID. And then the second one, I need to mention as sport ID. And for sport ID, I need to select sport table and I need to select sport ID from here. This is how the foreign keys are created. Okay. So I have added these tables and I have created the relations between them. Okay. Now I should go for the forward engineering. Okay. Forward engineering means from these tables which I have created, now I can go ahead and I can create the tables from here only. So schema name is given as MyDB. So inside MyDB, these tables are going to get created. Okay. And so I'm okay with MyDB. There is no problem with MyDB. If you want, you can change it. Okay. So let me change it. UNIVERSITY, university. So I'm changing it to university. Okay. And now let me go to the databases. And here I will go for forward engineering. Now I have created the model here. And with the help of the model, the laptop battery is going down. Okay. So with the help of this model, I'll be completing this particular. Yeah, skip the foreign keys. So I'm keeping everything as default. Let's go to next. And then select the option database to be created. So it's giving me no options here. Okay, now it is giving me an option. So let me write the password over here. So root is the password, and export my tables. I don't have any other thing, so I'll be just exporting my tables only. So next, and you can see that all the script has been written over here, and create schema university as well. And next, and it is executing for me. So this is creating the physical data model. You can manually create database that way, or you can do it this way as well. So close it, and let me go to the local instance here, and I should open a new SQL file. Into the new SQL file, let me write show databases, and let me execute this. So you can see that university as a schema or as the database. So it is here. And let me take you to the MySQL terminal. And here, if I type use UNIVERSITY university and show tables, so you will be able to see that the tables which we have created, they are here, and you can describe them, describe CLUB club, and you can see the same schema is here. So this is how you need to start from the conceptual model, then logical model, and then coming to the physical data model. And if you need this particular case study solved, you can request us. So here you can see the ER diagrams which are created for this, and then all the queries are written here for the physical implementation of the data model. And then some queries are also given. So thank you very much for watching. Keep watching, keep learning. Thanks a lot.
If you liked our video and would like to recommend it to your friends, please like, share and subscribe to Indeed Inspiring Infotech. We would also love to hear your suggestions and feedback in the comment section below.